5a and said, oh, I see a y there that has an coefficient of 1, yes? So I have 4x minus y equals negative 13. And we know we need to isolate one variable, yes? So what would happen to that y if I moved it over there? It would become positive y, and it would be by itself, wouldn't it? Except there's a negative 13 there. So what do I need to do with that? So I get 4x plus 13 equals y. Now, can I take that and put it in there? Yes. Understand? Everybody cool? You're just isolating y exactly the same way we would do it if we were going to slope-intercept form. Now, of course, that's what y is. So you would go 2x plus 3 times 4x plus 13 equals 11 and solve for x. And then once you add that x, you would put it back in there and you would get y. Right? Abso-smurfly. Now, we all know Braden S. already ruined the joke because he Googled the answer. But the joke is he wanted to see world peas. World peace. But of course, this is not an appropriate puzzle anymore because the current president wants no part of world peace. Oh, he is hoping for world peas. That's what it is. Who cares? It doesn't matter. The funny part is the world peas. Because that's why the veggies are in the blender. Because blenders whirl your food around. All right. Okay, this should then be page 178 for you people. Now, this is that next method of solving systems. Then after I teach you this, all of you should then yell at me, this was way easier, why didn't you teach it first? In order to keep with past class behaviors.
I'll make sure I say it even if I don't. Do you want us just to say it all? Do you want us all to say it?
I don't want you to.
1, 2, 3.
I haven't taught you the second one yet. You can't say it yet. All right. Now, I know that I said we were abandoning graphing, right? Because it's pretty useless, right? But it's useful in teaching you how this next method works. So we're going to graph this system. There's a blue line and a red line. And of course, as always, I need to put it in slope-intercept form. So I do get some extra practice with algebra anyway. So start putting that into slope-intercept form and start putting that into slope-intercept form. Go. And of course, you find the solution to be where you find the solution at Everybody should be able to do that, right? If you can't, you're in a bad spot right now. And I should be seeing some of you for help. Or I should be seeing some of you for you to come to say, Mr. Myers, I don't get anything you say to me, so I can find you another math teacher to help you. All right? All of you should be able to do that. Everybody good? All right, now listen. This is key. Every single one of you pick a number between -10, without saying it out loud, between -10 and +10. Every one of you pick a number. All right? Write it down, then multiply the second equation, so this one, by that number. Okay? Go. Don't look at the screen. There is nothing happening up there. Pick a number and multiply the equation by that number. I will never understand you kids. If there's a screen in front of you, put food in your mouth. You do it in here all the time, Braden. I say do something, and half of you sit there without writing a millimeter of pencil line. Multiply the whole equation by that number, just like it says. And then if you're feeling fancy, you could even do the next step, which is solve for y. While we are waiting for everybody to catch up, somebody say the number they used. 6. Lovely. And when you do all this work, what do you notice? You get, no, not just the same slope. You get the exact same equation, don't you? And you already know about this. What do you notice? Our solved equation, and I'm putting solved in quotation marks because we didn't actually solve the equation. Our solved equation is the same as before, right? So what does that tell us? Multiplying both sides of a linear equation results in a new, and I'm going to put new in quotes, because it's not really new, is it? A new equation, which we got right there, a new equation that is actually the same. Does everybody understand? Multiplying both sides of the equation didn't change the equation. What did it change? How it looked. Is everybody cool? We have seen this in math countless times. Is 1/2 the exact same thing as 14/28? Yes, because we multiplied that by 14 and we multiplied that by 14. We got the same fraction, but it looked different. We use it to add fractions, right? That's how we do it. Everybody knows this, right? Okay. You're smart kids. Oh, no. I'm going to hold off on that. You're still smart kids. Holy, that sounded awful. Sorry. Hold up. Never mind. Okay. Now, add the equations. Now, you have not done this in the past, but you have certainly added x's and y's and numbers, right? So let's do that. What is 4x's plus 5x's? 9x's. What is 3y's plus negative 3y's? 0y. And what is 0 plus 27? 27. Would we ever write 0y? No. So what would we really have? 9x equals 27. Now, before we go back to the graph, let's answer this question. What just happened? What just happened to this mess? We collected some like terms, but something happened. Y disappeared, didn't it? The y value disappeared. Now, y, and I know that sounds weird when we're talking about the letter. What is it about that that makes it impossible for you to tell me the answer? It has two unknowns, right? What happens now? We only have one unknown, don't we? Right? Now, what would you do with that? And what would you get? X would equal 3, yes? Now, if we go put that on the grid above, you don't have to. Don't bother flipping back. Here is x equals 3, yes? And what do you see? We eliminated one variable, and we got half our answer. Does everybody see that? Okay. Keep all this in your head. Let's subtract the equations. What's 4 minus 5? Negative x. What's 3 minus 3? Positive 6y. And what is 0 minus 27? How would we put that on the grid? I should have done that in a different color. Let's pretend I did that in green. How would we put that on the grid? Cursil. I would isolate y. 6y would equal x minus 27. Y would equal 1/6 x minus 27 divided by 6 is 4.5. Agreed? If you got it at your calculator, you'd find that. Everyone's cool? Okay, so let's go back up to our grid. Again, you don't have to do this. You just have to look. Negative 4.5, 1, 2, 3, 4.5, right there, yes? And the slope was 1/6, yes? So if I were to go up 1, would be right there to be 3.5, and out 1, 2, 3, 4, 5, 6. Agreed? It'll catch up. You see 2 green dots yet? Tell me when you see 2 green dots. There you go. And what happens when I run that? I'm through the solution again. So, what does that tell us? Adding or subtracting 2 linear equations. It doesn't tell us that. It's hard to write that. Results in a blah, blah, blah. A blah, 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 blah. There we go. A blah, 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 blah. Adding or subtracting 2 linear equations results in, again, new equations that still work with our eventual solution to the system, right? Okay, so now that you have seen this and you've seen it proven, what could you do? I want you to write one more equation that will have the same solution as this. How many answers are there? There's infinite answers to this. So should all 30 of you be able to write one of them? So go. There aren't 30 of you in here, I know. Blah, 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 blah. But I don't think that would be how it's spelled. Blah, 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 blah. Yes, it's bleh, but then it's a bleh, and then it's blah, 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 blah. Who would like to tell me one of their answers? Jacqueline, what do you think one is? 4x plus y equals 19. Correct! Who has another one for me? Now that Jacqueline has gone first, everybody should be willing to offer now because she's the one that's risked getting the no. How many people did that one? Okay, what's another option? What is another way you could have changed this? Jazri? 2x plus 3y equals 17. Yeah! Booyah, Grandma! What's another thing you could have done? Jacqueline? 4x. Oh, yeah. Okay. You... That one counts, but come on. That's a little cheap. Right. She subtracted. What else could any of you have done? Amelia. Right? And gotten 2x minus 2y equals 2. Or you could have multiplied the first equation by 4 and gotten 12x plus 8y equals 72. And so on and so on and so on. Right? If you wanted to, you could multiply by 1,562. That would be 1,562x minus 1,562y equals 1,562. No. Because you were trying to be a wise ass, and then I wise assed you right around being the wise ass. You were trying to be a wise ass. Yes, you were. It's all right. I'm the wise ass in here. I've got 40 more years experience at it than you do. I lie. 30 more years experience at it than you do. I don't need to add a decade to my life. I'm already getting old. Animal, it's time to go? Well, then go.
Bye, Animal. We'll miss you. What?
Everybody good? Now, here's something that kids always forget. That red one. What could you do that we haven't discussed that would still work? Gersahill. You could also divide to get x plus 2y equals 4. Alright? Because multiplying is the same as dividing. Dividing is just multiplying by a fraction. Right? Okay. You guys, I'm so proud of you. So, let us move along to solving by elimination. The first thing we're going to do in red is add or subtract the equations to get rid of one letter. Okay, so let's look here. If I add these equations, 3 plus 4, does that disappear? No. Negative 5 plus 5, does that disappear? Yes. So we are going to add them. What is 3 plus 4? 7x. This disappears, right? Equals what's negative 9 plus 23? 14. Step 2, solve for that variable. What would you do? So x equals what? Now that x equals 2, what do we get to do? Put it in where? Any spot that has an x. X is now 2. So which equation do you want to work with? Does it even matter?
No, I want to do the 3x one though.
Okay.
Yay!
3, not x.
3, 2.
2 minus 5y equals what? Negative 9. Start solving. He waited patiently. What kind of 15? No, negative 15. And y equals what? Because I chose to. I'm doing it on purpose, trust me. Y equals what? 3. Now, the reason Braden is questioning is because here, and I'm changing shades of green, he did this. 6 equals negative 9 plus 5y. He moved the 5 over there. Then he had to move this 9 over here, so the 9 became positive, and he ended up with 15 equaled 5y, and then y equaled 3. Did it matter? No. Who decides how to do the algebra? You do, but you still must follow algebraic rules. Now, do I now know the ordered pair? What is it? 2, 3. Do you need to come and check with me? No. Of course not, because what's 3 times 2? 6. What's negative 5 times 3? Is 6 minus 15 negative 9?
Probably. Yes.
What's 4 times 2? What's 5 times 3? 15. Is 15 plus 8 23? Yeah.
Correct.
Did we do it right?
Yeah.
Excellent. Now, this is when you tell me, this way's way easier. Why didn't you show it to us first? It's the same thing. Eliminate a variable, sub it in, do some algebra. It's the exact same thing. Now, this is where it gets tricky. Please read this.
Sometimes we will need to multiply one or both equations.
So, let's look at this first one. You finished?
I was at value.
This is Matt Myers reporting from room A301. Breaking news, Braden Curry can read.
It's astounding, I know.
Sorry, we'll have to come back to that one. It turns out we've had false information, and Braden Curry cannot indeed read.
I'm Kyle.
Oh, wait, he is a teenager, therefore he can only read if it is written on a screen.
Hey!
Looking at this system, will any of these variables disappear if I just add or subtract them together? No, and the title of this method is elimination, right? Is anything being eliminated? No, so I have to change the way it looks. How do I change the way it looks? I am allowed to multiply and I'm allowed to divide. If I multiply this by what? 2, what will I get? 2x minus 4y equals 14. Now, they have the same coefficient, and they will eliminate, won't they? Will they, one sec, Rylan. Will they eliminate if I add or if I subtract? I must add. Rylan, go.
So you can multiply one, not the other.
Yeah, of course. Yep. So what do I get now? What's 3x plus 2x? 5x. Y disappears. What's 1 plus 14?
15.
What does x equal? 3. What do I do? I know, she said 15. She sounded a little like Dr. Evil there.
She was so impressed with herself.
Now, what can I do with that? I can put it back where, Gersil? Does it have to be the first equation? Where can I put it? Anywhere I see an x. So for me, I would have to go to seashelled. Get it? All right. So 3 minus 2y equals 7. Solve it. Negative 2y equals...
10. Earlier, right?
Try again.
5. No, 4.
4. Now what? Y equals?
2.
Try again.
Negative 2.
Yeah! And what's our ordered pair? You do, because it says x is 3 and y is negative 2. So what's our ordered pair?
3 and negative 2.
Negative, now I'm screwing it up. 3 and negative 2. Did you do it right? Is 3, what's minus 2 times minus 2? Minus 2 times minus 2. Positive 4. Is 3 plus 4 7? So did we do it right? Is 3, what's 3 times 3? What's 4 times negative 2? Negative 8. Is 9 minus 8 1? So did we do it right? Okay. Now let's look here. Can I eliminate? No, I cannot. I need some of the coefficients to be the same, right? Just like if I had 1 over 5 plus 3 over 7, I need the denominators to be the same. Well, in this case, I need the coefficients to be the same. What's the easiest way to get the coefficients to be the same? Jacqueline? Could I multiply the top by 11 and the bottom by 2?
Yeah.
Then I would have 22x and 22x, and I could eliminate x. Yes. Could I multiply the top by 2 and the bottom by 3?
Yes.
Because then I would have 6 and 6.
Yes.
Does it matter?
No.
Which way would you like to proceed?
3 and the 2. Blue.
Red.
Let's flip a coin. Or roll a die. Let's roll a die.
Okay, 6.
Odds are the pink. Evens were the blue. Roll it. Nice catch.
That can be a...
Throw it as high as you can. Good job.
Just like all kids, you can't roll a die. Now, of course, it's on the floor. It doesn't count.
Fourth was blue. I think blue were even.
No, you said red was even. Red is even.
Pink
Red
was
is
awesome.
even.
Oh, let's do it again.
Red is even.
I'm just going to do both of them because by the time you guys figure out odds and evens, I'll have it already solved. If I use 11 and 2, I get 22x minus 33y equals 11 times 20 is 220. 22x plus 4y equals negative 2. Now, will I be adding or subtracting? Subtracting. 22 minus 22 is 0. Negative 33 minus 4 is negative 37y equals 220 minus 2.
Minus 2.
Yes, 222. Now what? Divide by what? And what does y equal? You'll need a calculator most likely.
Oh, wait, you have to divide that by 37.
6. Negative 6. Good. Somebody caught the negative. Now, if I went the other way with 2 and 3, I would have gotten 4x minus 6y equals 40 and 33x plus 6y equals negative 3. Would I add or subtract that one? That's add, right? 37x, this disappears, equals 37. What does x equal? 1. And now, whichever way I did it, I would then have the other letter to go back. Now, please notice this, while not frightening, kind of tough to do in your head, right? Keep the number smaller. Everybody understand? All right. That's it. That's elimination. Hey, Jaden, way easier, right?
It's easy. Why don't you show us?
Why you show it first?
All right. We all good? Now listen.
Yeah.
I want to have a quiz. Maybe we don't need a quiz.
No, we don't. No, we don't.
For this?
Then it's gonna tell us
What are we needing?
A quiz for this film?
We'll see. Page 179, I believe, has elimination practice. 181. Okay. But then on 182, you can do another one of these.
Can we just pick one of the pages?
Yeah, of course.